Okay, now we're going to move through the chapter. So we'll talk about chapter F 4.8, which covers data fusion and merging classification streams. So the idea is to show you a few different ways of moving and synthesizing information from different land cover classifications that we can assemble through time in a particular area. And so the learning outcomes, as you see here, is we want to have you realize that we're not talking about merging sensor data, in which you might merge, get data from synthetic aperture radar and statistically fuse it somehow to information from Sentinel-2, let's say. But instead, in this case, we're talking about combining information from classifications that have already been made. We'll walk through working with the Bayesian updating of land cover algorithm to blend classification from across multiple years. And then I'll also show you the bulk D algorithm for highlighting locations that have changed, either through deforestation or regrowth or some sort of change, sort of as an alert system. What we assume you know how to do is to look at images and image collections from F1, how to select bands and compute indices and create masks and classify images. You don't really do that precisely in this lab, but understanding it is pretty important. How to create or use graphs with UI.chart, that's also interesting. And how to get accuracy metrics from classifications. So I will move down to section 1. And so what we want to look at is a particular area in Brazil and in Mato Grosso that was formerly very, very remote from agriculture, that has now over the years been changed over quite quickly and recently to agriculture. One of the papers that uses bulk that I showed in the introductory slides takes a land cover series all the way up to 2016. And so what we're interested in doing in this section is moving from 2016 up to 2020. So you can imagine that we have, for Sentinel-2 data, we might have a few images from there, February 8th and July 7th, May 28th, but all from different years, 16, 17, and 18. And basically, we've selected here 2 images from different sensors for each of the years from 2016 to 2020. So 2 or 3 images, including one that we haven't even mentioned today that's used sometimes, Aster. We have produced classifications of each of those. And to begin to show you the set of events that we'll use, we will go to code checkpoint F48A. F48A contains this code here. What this code does is it brings in an image collection that we have produced and stored in the set of assets for the book. We then print to the screen the list of events and the number of events. And then we do this very interesting command called UI.thumbnail. You may have seen that in other presentations. And the idea of UI.thumbnail is it takes in a set of images, an image collection, and then draws with a particular palette. It sort of makes a video. And so this one will do 1 frame per second with where the dimensions are constrained in order, and what that does is it affects the resolution. So what I'll do is now change to this view of F48A, where you can see I've already clicked on it, and so it's kind of embedded in there. And I'll run it again just so that you can see, but this is now, just to repeat, found down in F48A as one of the checkpoints. All right, so we can see several things, I guess. One is there's a lot of black, and what that black refers to in this case is no data. It's not a true class. It's just a place where there isn't any information. And so you can see that missing data for some of the classifications where the data is served in small tiles. You can see some missing data, like here in these big blocks, but you can also see some missing stripes. Those are from Landsat 7, which had a failure on board that blanked out percentages of the images, but a lot of the image information was there. So with our eyes, we can look at, with our eyes and brains, you can, if you can remember through the black missing data, you can see that there seems to have been some change, but also that it's an agricultural area, and also that there's perhaps noise in each of those classifications. And so that's what we'll do in the next section.